Okay, cool. Right. So let's go. So now we're dealing with the second part of the rule, which is where we have two tangents to a circle, right? So I call it rule 4a, but it's not necessarily correctly called that. Anyway, we have two tangents to a circle. All right. So if you open, you're going to see the first diagram, right? So we have a circle, and we have two tangents coming from point B and touching the circle, the same circle at two different points. Point A. Well, let me get my little thing going here. Right. Point A, and then point C down here. And the rule we learned just now was what? What is the angle between a tangent and a radius at the point of tangency? The angle formed is 90 degrees. So this angle up here at A is 90 degrees, so that's OAB. And this angle down here, which is OCB, that's also 90 degrees. So far so good? Alright, we're going again. So note, right, when two tangents originate from the same point external to a circle, and touch the same circle, the distance from the point of origin to the points of tangency are equal. So this is the point of origin here, the point of origin of the tangents. This is one point of tangency, point A. This is the other, point C down here. So the rule says when the two tangents originate from the same point and touch the same circle, the distance from that point to the points of tangency are equal, which means that AB and CB are equal, right? So what this means is that in the diagram above, BA is equal to BC. And what's the emphasis? Come, Liam. Right? BA equal to BC. Those two lines, right? I will blink in. Going again. All right. So the shape ABCO is a quadrilateral. It means it has how many sides? 4 sides. What you blinking? Blink, 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 and then blank, blank, blank. Right? Cool. So we have two angles there. Now, we know that the sum of the internal angles of a quadrilateral is 360 degrees. So, it means therefore that the angles at A and C add up to 180 because they are both 90. And what does that imply about angle Y and angle X? What will they add up to? Anybody? Correct. If the sum of all the angles in the quadrilateral add up to 360, and these two angles at the points of tangency already account for 180, the remaining angle of 180 must be accounted for by the remaining angles at, well, X and Y. Alright, so those are 90 there. So the angles at B and O must also add up to 180. So those two angles there. Alright, cool. So observation 1, X plus Y. So you guys have to write this in on your handout because there's a little blank line there. Right, so X plus Y would be, yeah. If it's not there, it's actually not in back. You should see it there. Observation 1. Yeah. X plus Y is equal to 180. Alright. So that's the first observation that we made. Alright, so let's see. I think you have to turn the page now. So now we have a line from B to O. That's the purple line, and it cuts the shape in half, which means that the angles at X and Y are also cut in half. So we're going to replace X and Y, right, with small a and small b. Now, the angles in a triangle, sorry, let me move this thing here. Right, the angles in a triangle must sum to 180. So A plus B plus 90, sorry, A plus B plus 90 must add up to 180. Right, so remember this result, we will need it later on. Right, so observation 2 is that A plus B is equal to 90. This one down here. Right, and we saw that because when we drew the purple line, we cut the quadrilateral into two triangles, two right angle triangles, and this angle is 90. All the angles add up to 180, which means A plus B is 90. Alright, we're going again. Alright, so now a line is drawn from A to C, perpendicular to OB. Alright, so that's this line, this orange line coming down, and perpendicular means it meets OB, the purple line at the right angle. So the orange meets the purple at 90 degrees. So we're cutting this shape into even more pieces. So now we have each triangle that was half of the initial diagram is now cut into a big triangle on the outside here and a small triangle inside the circle. Alright, So we're going to consider this new triangle. Alright, so we disappear some lines. So you see on the board some lines disappeared. So we have this triangle here with some some sides that don't stop at the vertices. Alright. So we can see two of the angles, A and the 90 degrees. Right? So here we see in the A and the 90. What was the observation we made just now? With A and 90 and another angle. A plus B plus 90 is 180. Right, which means A plus B is 90. So if we have this same triangle with A and 90, it means this angle on top of here, right, the third angle can be found using our earlier observation of A plus B plus 90 is 180. So if we need A and a B and a 90 to get 180, this angle here must be B. Alright, the missing angle is B. Right.
We have 90.
Mm-hmm.
So we need a B.
Yeah, need a B.
So
yeah, right. So all that's happening is that when you drop in more lines in the triangle, you kind of rearrange where the angles go. Alright, so we can therefore deduce that the missing angle is B. Alright, boom. Alright, so now we're going to reintroduce some lines from before. Alright, so we brought in some of this. So we're seeing that we have a B up in this corner here, and we have a B down here. Okay, and those are the same angle, eh? Now it's not F angles or Z angles, right? It's just how this thing was drawn. Alright, so now you saw we have a little 90-degree angle being formed here. Let's disappear some other lines, right? So what's the value of this missing angle on top of here? So that angle at the top there. Correct. Right? So if we get rid of a lot of the other things first, like I said, if we declutter the diagram, we could focus on the parts we want to see. Alright? So the two angles visible are B and 90 degrees. Our earlier observation is used again. A plus B plus 90 is 180. So if we have a B and a 90, the third angle must be A. Right? So this means that the missing angle is equal to A. Alright? So see if you have to fill that in somewhere in your paper. I'm not sure. Oh, no, I have a copy here. Right. There you go. A. Right. So now let's see the whole picture. So check this, right? We're going to reintroduce a bunch of lines here. And we're going to insert. So remember the shape on top and the shape below are reflections of each other. So all the angles we found in the shape above can be put in the correct and corresponding places in the shape below. Right? So that this purple line is like a mirror line. Alright, so now, so check what happened here, right? So we drew two lines coming from A and C, and they touch this point on the circumference, right? So consider if two lines were drawn from A and C that met at the same point on the circumference. What is the angle formed at the circumference? So once again, if we remove some lines, we might see it more easily. Aha! What does this look like from the previous set of rules? Which rule? Angle in a semicircle, angles in the same segment, cyclic quadrilaterals, none of those. What about the angle at the center is double the angle at the circumference? So this angle at center here. So this is the arrowhead. Look at this, the arrowhead rule, isn't it? What's that? Yeah, I know. Then take it piece by piece and digest it. Alright. Alright, so we use the rule from before. The angle at the center of the circle is double the angle at the circumference. So the angle at the center is double this angle here. Right? So angle at center is 2b, right? Because you have B and B, which is 2b. Therefore, if this angle here is double that, this has to be B. Alright, so the angle at the circumference here is B. Alright. So now we've reintroduced all the different lines there, and that is the end of the handout. Alright, so we're going to end the recording there.